So we're going to walk through Lab 3. This is about a hello world task of figuring out how we can learn the simplest thing possible from the stream of data. What are the proportions of the different things that we see in that stream? So you can read the setup here. Basically, we've got two boxes. So I'm going to just run the imports here. We've got two boxes. In one box, we've got 600 beads of one color, 550 of a second color, and 350 of a third color. So pretty evenly divided between the first two, and then a few less of the third color. And in the second box, we have 100 of the first and third, and 1300 of the middle. So this is a much less evenly divided box. So I'm going to represent this as a tensor, and use a floating point value for this, so that we can keep track of how many items are in each box. So what we're going to do is we're going to find a way of making an observation. So this is a two-step observation process. So we're going to first pick a box. So that's just a random number equally likely to be 0 or 1. Let's draw a couple. 1, 1, 1, 0, 1, 1, 0. So equally likely to be 0 or 1. And then once we have a box, in this case we're going to look at box 0, we're going to use this code to draw a sample of what beads of different colors that we got from that box. So for example here, we're going to get 5 beads from box 0, and we get, in this case, 1, 1, 1, 1, 2. So that corresponds to middle, 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 right color, where we said that the colors were red, orange, or yellow. So orange, 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 yellow. So now we're going to try to figure out what the true proportions are, and then we're going to try to estimate them. So the true proportions is just a exercise in doing some tensor arithmetic. So what we're going to do is we're going to take our boxes, and so we're pretending that we know what the real values are right here. So this is not yet at the learning part. We're just doing some tensor practice. So we're going to sum over how many beads are in each row. So each row corresponds to a box. So how many beads are in each row of the tensor? Let me just show what boxes looks like right here. So we've got we want the first sum to be 600, 550, 350. So whatever that is, it should sum to 1500. And the second sum will be actually the same, 100, 1300, 100. So they didn't have to be the same sum, but I set it up to be the same sum so that you wouldn't be confused about that later. But let's just try summing up the number of beads in each box. If we just do sum, that gets the total sum across the entire thing, 3000. But if I want to do the total number in each box, I need to give it an axis to sum over, or sometimes you might see dim, but I like to call it axis because that's what NumPy uses. So depending on what axis we give, we can get a different way. So this is the total number that we're summing across axis 0, which is the boxes. So this would be the total number of red beans, orange beans, and yellow beans. So that's interesting, but that's not what we wanted. So let's do across the other axis, axis 1. So here we have 1500 beads in each box. Now that's convenient. So let's remember how axis shapes work. So look at the shape of this tensor here. So we have axis 0 had dimension 2, axis 1 had dimension 3. So in this setting here, when we say we want to sum over an axis, that means that axis is going to collapse. So we're going to have, when we summed over axis 0, then the dimension 2, or the axis 0 with 2 in them, went away. We were left with a single tensor of 3 elements. So just to make this obvious, we can do dot shape, and there's our 3. So the 0th index went away. So when we put it back to axis 1, now we have just the axis 1, that 3 went away, so now we have 2. So what I want to do is now divide these numbers by these ones. So if I had different numbers of beads in each box, I'd want to divide each one by the corresponding number. So if I just do, if I try to say boxes over that, then we get a runtime error because these dimensions don't match. The way that broadcasting works is it tries to match all the way up to the last dimension. So If we'd done this on axis 0, it actually would have worked. So this would be the correct proportions between the two boxes of the two beads, but that's not the direction that we want to go. We want to do these proportions among the beads in each individual box. So we sum across the beads in each box, but then we're left with just a little dimensionality matching issue because PyTorch and NumPy or whatever else you're going to use doesn't know which axis we need to use to sum over. So I just give it the keepDim parameter, and then that gives us a tensor here that's of the right shape. So instead of collapsing it, what this did is it gave us a tensor that, you see how these numbers show up in a column here? That's kind of keeping it in the same overall shape as this one. It's not throwing away that 3, the axis corresponding to that 3. It's just collapsing it down to one number each. So this is a convenient thing to do. There's also other ways of viewing or unsqueezing a tensor to do this, but keepDim is nice to be able to make everything still align. So here's our way of figuring out, using our keepDim true, we can find the portion of beads in each box. And this matches what we summarized earlier, that there are 40% red, 36% orange, so about equal here, and 23% yellow in this box. So this box is pretty evenly divided, red and orange, and a little bit less yellow.